Hey, all, today we're going to stay with transformations, and we're going to talk today about rotations. So I want to rotate my point Q in my coordinate plane uh, several different ways. So the ways that we're going to rotate are 90 degrees, 180 degrees, 270 degrees, and we'll talk about what it means to rotate 360. So you might be asked to rotate clockwise or counterclockwise. So clockwise would be uh, in the way the clock goes, around to the right. And so what's really nice is if you have a graph like this, you can literally rotate your page and then read your new coordinates. So right now I have coordinates for Q of -3, -2. And so if I rotate that clockwise this way to the right, 90 degrees, I have new coordinates. Now I need to look at my coordinate plane as if nothing happened. So even though this is y, this is my x-axis, and this is my y-axis. So now my coordinates are -2, 3. If I rotate 90 more degrees, which is a total of 180, and I look at my coordinate plane as if the coordinate plane didn't move, just my point, now I have coordinates of 3, 2. And if I rotate one more time 90 degrees, which brings me to total rotation of 270, my coordinates are 2, -3. And then if I rotate another 90, which brings me to a 360-degree rotation, I did a full circle, my point is back to where it started, and so its coordinates stay the same. So if you try to rotate something 360 degrees, it's just going to stay the same. So that's as simple as it gets. You just rotate your paper and then write down the new coordinates. So let's do another one. My coordinates for P right now are -1, +3. I want to rotate it clockwise 90 degrees, so I'm going to rotate it to the right 90 degrees. And my new coordinates are 3, 1. If I want it 180, I do it 90 degrees more. And I get coordinates of 1, -3. 270 degrees is 90 degrees more than that. My coordinates are -3, -1. And then, of course, 360 means my point just went right back to where it was. It's a -1, 3. And there is a pattern that exists here. My original, when I rotate at 90 degrees, I switch the order of my x and y. So I put the 3 in front and the -1 at the back, and then I negate this value. When I go from my original to 180 degrees, I just change the sign of both numbers. So -1, 3 turned into 1, -3. When I rotated 270 degrees, I took my original coordinates and I changed their order, and then I negated the first one, -3, -1. So there's a way to do this by using a rule, or you can just rotate your paper. I find rotating your paper kind of be the most straightforward way to do this. Counterclockwise, we'll do the same thing, except counterclockwise means we're going to the left. So my original point Q at 1, 3 goes to the left 90 degrees, and my coordinates become -3, 1. Another 90 degrees gives me 180. My coordinates become -1, -3. 90 more degrees gives me 270. My coordinates become 3, -1. And of course, a 360-degree rotation puts Q right back where it started at 1, 3. So I want you to do your best. Try this one. Make a sketch of this. I'll tell you the original coordinates are -4, +4 for P. I want you to go counterclockwise. So that means to the left. And I want you to find the coordinates for a 90-degree 180 degree, 270 degree, and a 360 degree rotation. Try that one now, and then press play, and we'll go over the answers. So if you rotate 90 to the left, you get coordinates of -4, -4. 180 degrees, you get coordinates of 4, -4. 270, 4, 4. And then, of course, if you rotate it all the way back around, you get the original coordinates. So that's it for rotations. If you have any questions, make sure you're ready to ask them in class, and we'll do some practice.